In a previous chapter, we've already learned how to conduct a hypothesis test on the population mean or on the population proportion. In this section, we are going to learn how to conduct a hypothesis test on the population variance. Variance is something we've talked about before, but very briefly. It is very simply the square of the standard deviation. In statistics, we tend to use this quantity a lot, so we give it a special name. We call the square of the standard deviation the variance. We conduct a hypothesis test on the population variance much like we conduct a hypothesis test on the population mean or on the population standard deviation. But there are a few differences. Perhaps the most significant is the test statistic we use to calculate to conduct the hypothesis test is different. A test statistic is a quantity that summarizes the data in the sample. When we did hypothesis tests on the population mean or on a population proportion, we calculated a z-score or a t-score to conduct the hypothesis test. The z-score, the t-score, those were test statistics. Okay. For the population variance, to conduct a hypothesis test on the population variance, a test statistic we calculate is n minus 1 times s squared over sigma squared, where these variables all mean the usual thing. N is the sample size, s is the sample standard deviation, and sigma is the hypothesized population standard deviation. And if we look at the distribution this gives us, it ends up being a chi-square distribution. So our sampling distribution is a chi-square distribution where the degrees of freedom is one less than the sample size. Okay? The basic steps of a hypothesis test remain the same. Step 1, state the null and alternative hypotheses. Because we will be conducting a hypothesis test about the population variance, our hypotheses will be in terms of the population variance. Step 2, assuming the null hypothesis is true. Assuming the null hypothesis is true, identify the sampling distribution. That sampling distribution will be this chi-square distribution with n minus 1 degrees of freedom, where n is your sample size. Okay? That's the sampling distribution we're going to use. Once we have that sampling distribution, we can find the p-value. To find the p-value, we're going to use our chi-squared distribution, that's our sampling distribution, and we're going to use our test statistic. And we'll use that test statistic to calculate the p-value. And finally, once we have the p-value, we can compare it to our level of significance alpha to draw a conclusion.